All right, let's talk about something that can strike a little bit of fear into the heart of almost anyone, the math word problem. But today, we are going to crack the code on these things, and we're going to turn all that confusion into total clarity.
You know that feeling, right? You stare at a whole paragraph full of words and numbers, and you can just feel your brain wanting to check out. Trust me, you are not the only one. It's so easy to get lost in the story before you even get to the math.
I mean, just look at a problem like this. In the town of Tranquility, each of 5,285 families has 0, 1, or 2 children. It just keeps going. It feels way more like a brain teaser than a simple math equation. And that's exactly why they feel so intimidating. There are so many pieces to juggle.
But, and this is the great news, there is a secret. A really simple, totally reliable method that works every single time. And by the time we're done here, you're going to have it.
Okay, let's dive right in. We need a little shift in perspective. We're going to stop thinking like students and start thinking more like detectives. Because really, every word problem is just a case waiting to be solved. And every case has clues. We just need the right tool to find them. And here it is. This is the tool. It's a super simple 3-step framework. First, you figure out what the problem is actually asking. Second, and this is the big one, you translate the words into math. And third, you just solve it and double-check your work. That's it. It's really that straightforward. Now, I've got to say, step 2 is the absolute game changer. Translating words into math, that's the real skill here. This is where we break the code. Once you get good at this translation part, the rest is honestly just calculation.
So, enough theory. Let's put this new tool of ours into practice. We're going to open up a couple of classic case files that involve money. This is where we'll see how it all works in the real world.
All right, here's our first case. Dora has a bank. It has 4 times as many quarters as it does dimes. The total value is somewhere between 10 and 12 bucks. How many of each coin are in there? Now, it sounds like a lot, but let's not get ahead of ourselves. Let's just look for the clues. So, what's our first move? We go right back to step 2, translation. We've got to pull out those key phrases from the story and turn them into something we can actually work with. So what are the most important pieces of information here? And this is just perfect. Look how beautifully this illustrates the whole process. Every single clue from the story has a direct translation into math. 4 times as many quarters as dimes just becomes Q equals 4 times D. The total value is just adding up the value of the dimes and the quarters. See what we did? We just turned a confusing story into a clear, solvable equation. That is the secret. Now, what's really cool is that this detective tool isn't just for complicated algebra. Sometimes that translation step doesn't give you one big fancy equation. Sometimes it just tells you that you need to be really organized and logical. Take this case, for example. Cookies are 15 cents, brownies are 25 cents. What different combinations can you buy for exactly $1.50? You see, there's not one single equation to solve. Our translation of the problem tells us we're looking for different combinations that hit a specific target. So the solution here is just to be systematic. Let's start at the edges. What if we only buy cookies? Well, 10 of them gets you exactly $1.50. Perfect. What if we only buy brownies? 6 of those works too. And then we can just test the combinations in between until we find another one that fits. 5 cookies and 3 brownies. The point is, our strategy came directly from translating the problem's goal. Let's keep going and open our next case file. This one's all about division dilemmas. You know, when you have to split things up, which usually brings in fractions or ratios. Okay, check this out. A man has 4 children and 48 horses. He divides them up so that each child gets half as many horses as the next older child. That last phrase, that's our master clue. Everything else is going to flow from that single piece of information. So let's just make sure we understand that rule. It creates a chain reaction, right? The second oldest child's share is completely dependent on what the oldest gets. The third depends on the second, and so on down the line. Getting that relationship clear in your head is the absolute key to cracking this case. So if you work backwards with this rule, testing out numbers, you find that there's really only one combination that works. The oldest gets 25 horses, the next gets 12, then 6, and finally the youngest gets 3. And if you add all those up, you get a grand total of 46 horses. Which means, with 48 horses to start with, and 46 given away to the children, the number of horses left over to be sold is exactly 2. You see how decoding that one key phrase just led us straight to the answer? It's pretty amazing.
So we've solved a few different cases here. But what's the real answer? What's the big idea we're supposed to take away from all this?
It's this, right here. The secret to cracking word problems was never about being some kind of math genius. It's always been about being a good detective, someone who can read carefully and spot the clues hidden right there in the story. So here it is, your own personal toolkit to take with you. Just remember, the clues are always there in the text. Your only job is to translate them. And this simple 3-step tool, find the question, translate, and solve, that is the universal key that will unlock any word problem you ever come across. So the next time you see a block of text mixed with a bunch of numbers, you're not going to feel that dread. You're going to see it for what it is, a puzzle, just waiting for you to solve it. You've got the tool. You know how to be the detective. So the only real question left is, what mystery are you going to unravel first?